Well, good morning, class. Sorry that I'm not with you. My kids have a snow day today, which means that I have to stay home. So sorry, you guys just kind of keep missing out on all these snowstorms. Well, today we're going to be looking at 7-7, which is very similar to what you guys did yesterday, only today you're going to be dealing, with special products. So what I want you to do is we haven't been using these tiles, and this is from something from yesterday, so don't look at this. We haven't been using these tiles, but what I want you to do is think about how you would factor something like these two. Just try these two, okay? So what I want you to do is pause the video here, and I want you to talk to your neighbor and talk about how do you think we could factor this, okay? Just like what we did yesterday, all right? So go ahead and pause it. All right, hopefully you tried that with your neighbor. And what you probably would have maybe come out with is the only way to get 4x is either to be using 1 and 4 or to be using 2 and 2. And after maybe you tried a little bit, you would have landed on the fact that this was a 2x and a 2x. This would only be 1, so that's kind of nice because that one's easy. And then because this is a subtraction sign, which is in front of the C, notice it's in front of the C value, my signs have to alternate, so 1 plus and 1 minus, okay? In this one, again, maybe after you did some trying, the 1 would be really easy because, again, we don't have any other way to get 1. Because this is a plus, we look back, we notice that these are both going to be subtractions. Now, for the 4, you might have had to play around. Should you use 1 and 4 or should you use 2 and 2? And you should have noticed that it was going to be a 2x and a 2x. Well, what today's lesson is all about is looking at those special products. We actually did this in lesson 7-4. In lesson 7-4, you looked at these two binomials and we noticed that when the signs alternate, the middle term drops. So basically, today is just reverse of 7-4, okay? Now, this one, because the signs alternate, you do have to write both binomials. Now, it doesn't matter which one comes first, but you do have to write them both. In this one, because the binomials are exactly the same, you can write it as quantity squared. So that's typically how you would see that one written, okay? Now, I know you haven't tried these ones down here, but what I want you to notice is, do you see how C is very similar to B? The only thing that's different is instead of being a subtraction, they have a plus. So this one, it's going to look the same. So this is going to be a 2x plus 1 quantity squared. Now, if we go to D, notice the 6 in the middle. So that one right there, we're going to just have to work out. There's no kind of trick to that one. They kind of threw that one in there just to, I think, kind of to get you to see the difference between the specials and the non. So in this one, clearly, again, the 1 and 2 would be your easiest. Because this is a plus, when we look back, since we know they're both going to be subtractions, now we just have to try the 4. Part of me almost thinks to try a 4, because 4 times 2 would get you 8. But then are we going to be able to get rid of the 6, or get rid of 2 to get down to 6? So I'm thinking this. So when I multiply here, that's 8x, but then this is only, negative. Then this is a negative 1x. That's 9. So it doesn't look like the 4 was probably my best bet. But again, sometimes you don't know that until you try them. So that's a negative 4 now, and now that's a negative 2. So there's my negative 6. So this one really is not a special product. That's just kind of like what we did yesterday. So you're still going to see some of those ones mixed in, okay? So if you turn to page 235, they just have a few more that we can, maybe look at here in a minute. But what I really wanted you to get to was the bottom of page 236. On 236, they have the core concepts, and again, they're nice to kind of look at. So when you're given something in this form, or you can kind of see it here with the numerical one, x squared minus 9, or let's say x squared minus 25. When you have what they call the difference of two squares, if you notice, they're going to alternate. So see how it's alternating, a plus 3 and a minus 3, okay? When you go down here, notice how you have a middle term. So you just have to watch. If the middle term is a plus, then obviously the binomial is a positive. If the second symbol is a subtraction, then the binomial is a subtraction. So again, if you look at this example, see how it's a plus 6? Well, then that would take the square root of 9, which is 3, so then it's x plus 3 quantity squared. And then this one's the same thing, square root of 9, but now you need the subtraction, okay? So these are just kind of unique ones. Again, if you look back at 7-4, you were able to do that homework a lot faster if you used your tricks, okay? So let's go to page 237, and I'm going to do one with you, and then maybe we'll have you pause it and try a couple, okay? So on this first one, notice it's s squared minus 49. So we know we're going to have two binomials. We know it's going to be s and s. We know because this is a subtraction, they're going to alternate. And the square root of 49 is 7. So notice it's a positive and a negative 7. That's the only way we're going to get our middle terms to drop. Also, if you look, notice it falls underneath this one. So you're looking at this pattern to get them to drop, okay? All right, so I'll try 2 with you. So again, we're going to use our two binomials. Subtraction, so we know they're going to alternate. And then notice the square root of 81 is 9. Now again, it doesn't matter which one you do first. I just sometimes have a tendency to always do the plus one first, but it doesn't matter. So why don't you go ahead and pause the video here and try these 4. Don't go past the line below, just try those 4. Okay, hopefully you tried them. Notice number 3 is backwards, but that's okay, it's not a big deal. You still have the square root of 16. You know the only way to get x, and then your signs have to alternate. And that would be your answer. So they're kind of grouping it all together with this difference of 2 squares. Now in this one, notice we do have a coefficient out front. So we're just going to take the square root of 4, and then obviously g, so square root of 4g squared, and then the square root of 25, and then our signs alternate. Okay? So not too bad. So this would be 6h minus 11, plus 11, and then 6h minus 11. And then this would be 9 plus 7k, and then 9 minus 7k. Okay? Now, I'm going to come back to this section. We kind of looked at this again, I don't remember if it was 7.3 or 7.4, but I'll come back to this. But I want to keep rolling with how do we factor these things, okay? So turn your page over to, or whichever it is in your book, to 238. And we're going to take a look at the other rule here, okay? Now, this is the rule, if you notice, they call it the perfect square trinomial. So we have the plus and we have the minus, okay? So if we look at number 13, or these two right here, notice we have the plus, okay? So we're going to take our two binomials, and we take x and x, and then the square root of 64 would be 8. Now the symbols, again, because this is a positive, when you look back, that means they're both plus. So actually we would write this as x plus 8 quantity squared, okay? Now, this one's going to be the same because of the pluses, okay? So I'm going to skip this one for a second, and let's do a subtraction one together. So notice that's going to fall under the same rule. It follows the same rule, it's just you have the subtraction sign instead of the plus sign, okay? So we're going to take our two binomials, and we're going to have r and r. Now, if you don't know what the square root of 169 is, then you can just type that in. Whoops, not pi. Square root of 169, and you get 13. Okay? So this will be a 13. And notice this tells us the signs are the same, and we look back, they're both subtractions. Okay? So then we're going to write that as r minus 13 quantity squared. So why don't you go ahead and try these 4, okay? So go ahead and pause the video here again. It should only take you a couple minutes, but go ahead and pause it and try those 4. All right, hopefully you tried them because, again, you have to try these on your own. Now, I know I'm not there to answer questions, but there's a lot of people in class who do understand these. So if, the sub can answer questions, other students can answer questions, but you have to try them before you see me go through them. Okay, now 14 is very similar to 13, so we know it's going to be repeated. So instead of writing it twice, I'm just going to skip that step and I'm going to do quantity squared. So I know it's p, I know it's a plus, and then you just got to take the square root of 196, which is 14. All right, notice this one and 17 are kind of the same because of the two pluses. So let's go ahead and go down here and do this one. Now, you should have noticed you have a coefficient in front, which is not a big deal because it's a perfect square. So that's going to be a 6c and a 6c. Sorry, I don't know why I just wrote them twice again. And then 49 is 7 and 7, and then plus. So this is 6c plus 7 quantity squared. Okay? Notice 16 and 18 are similar. You got the plus on the end and then the subtraction. The only difference is this has a coefficient out front. So we know this is going to be a subtraction 1 quantity squared. So we take the square root of a and the square root of 81. And then the same thing here, where I know it's going to be a subtraction squared. The square root of 100 is 10, and the square root of 1 is 1. So that one's nice. Okay? Now again, if you don't like these, or if you don't recognize the trick, then you just have to try to, work it out like you did yesterday. But notice they're giving you perfect squares, so today's should actually go pretty quick, okay? Down on the bottom, we've seen this before. Notice the word solve, okay? So what you have to do, if they don't give you the 0, is you have to create the 0. So number 19, it's kind of what I would say it's ready to go. Notice it's got the subtraction, so it's following this one right here. That's following that rule. So I know they're going to alternate because that's the only way to get my middle term to drop. So this is going to be an x plus 12 and an x minus 12. Then, just like we saw before, we set each one equal to 0. So that's the positive one equal to 12, and then the negative one equal, sorry, not to 12, to 0, early. This is x is equal to negative 12, and x is equal to positive 12. And those would be your two answers. Now, to do number 20, we have to move the 49 to the other side, which is not a big deal. We can subtract it. Now, once again, perfect squares, okay? So we've got 3y plus 7 and 3y minus 7, okay? And then if we solve each one of those, we're going to get y to be a negative 7/3 and y to be a positive 7/3. That would be our 2, okay? Now, I know you guys don't like fractions, so I'm going to jump down here to 23 and 24 because I do think it's good to try a fraction from time to time. So on this one, I'm going to move the 1/9 to the other side. So we're going to get that, so we have everything on the same side. So it's plus 1/9. Now, if you notice, that is a perfect square because the square root of 1 is 1, the square root of 9 is 3. So this one falls under this rule. You have a perfect square in the front, you have a perfect square in the back. Okay, so see it says perfect square trinomial. So you're going to have n plus, and then you're going to take the square root, which is 1/3, and then quantity squared. So really it wasn't that bad. Okay, now you solve it, so it's just n is equal to negative 1/3. Because it's the same answer twice, we don't have to write it twice, we only write it once. Now this one, notice again, my k squared is by itself, and I do want it positive, so I'm actually still going to move this one to the left. I could move these two over here, but I want my k squared positive, so I'm going to move it right out front, which will turn it positive. Now don't let that middle term bother you, because the middle term, it's going to be your outers and your inners together, but this is perfect, okay? Today is all about tricks or perfect square ones, so the numbers come out really nice. All right, so we're going to have our parentheses squared, but notice because this is a subtraction, unlike the number 23, we're going to have a subtraction in the middle, okay? So the square root of 9 and the square root of 25, and then if you solve this, that would just be k is 3/5, okay? So not too bad. The tricks are not too bad. They go pretty fast. Why don't you go ahead and pause it here and try 25. I know you guys don't love story problems, but you really do need to give them a try. So please pause it, try number 25, and then we'll see how you did. All right, hopefully you paused it. The correct answer would be x is 3/2. That would be the correct answer if you worked it out. Now again, I'm not there to ask you if you did it okay, but if the class feels like you're fine, I guess you can go ahead and stop here or move on to the next section. What you would want to do, because you're dealing with volume, is you'd want to multiply all three together. So that would be, I like to do my constant out front. So that'd be 4, and then times your parentheses here is equal to the volume, like that. Now it's just a matter of getting this thing cleaned up. So you really just have to kind of go slow. Trust me that when you FOIL that out, so I'm ignoring the 4, when you FOIL this out, you get x squared plus 3x plus 2. That's just what you get when you FOIL. Now we still have the 4 out front, okay? So if I distribute the 4, that's what I have. Now I still have this on the other side. Now I got to move it all over to the left here. So if I move the 24 over, that would be a minus 12x, and if I add 1, that would be a 9. Oh, look at what I have here. I have a perfect square in the front, I have a perfect square in the back. How convenient. So this one is the rule where it's going to be doubled. And again, kind of keep referring back here, you're going to see it's got the subtraction, right? So it's this one, okay? So it's that rule. So we've got the square root of the first, the square root of the back, and notice my signs are the same, so I look back, they're both subtractions. And then when you solve that, that's how I get this answer, okay? So I skipped one section, and it's this one. We talked about this last week. Again, I can't remember if it was in 7.3 or 7.4. To me, this is a dumb question. I cannot see them asking you this on a no calculator because squaring 57 squared is huge. I mean, I cannot believe anybody would ever give that to you on a no calculator. So if somebody gives it to you on a calculator, then why wouldn't you just simply type it in to your calculator like that and just figure out the answer? So I'm not going to work this all out. But basically, again, what they want you to do is notice how close these are to 50. So remember how we wrote them one time? How we wrote them like, you know, this is 50 plus 7, and then it's quantity squared. And then this is, 50 plus 7. And then this would be like 50 plus 3, quantity squared. Remember how we did that? That's what they want you to do again. But it's really very pointless. Nobody in their right mind would ever do this. So I'm not even going to worry about it, okay? It is not on the test. It's not on the homework. It's not on the exam. None of that sort of thing, okay? So hopefully today went pretty well, and I'll be back with you tomorrow. I do want to just remind my classes, I think I did not do this for my second hour, but on the bottom of your 7-6 notes, so on the bottom of 7-6, if you want to try to solve this for extra credit, this was I believe it was number 20. It was the very last one. It comes out to be a system. So if you want to solve this for some extra credit points, please show it to me on Friday, okay? But you do have to have all of the work. You cannot just guess and check. Does that make sense? Okay, I will see you back here on Friday. Have a great day.